Hello! In this video, I will explain what RGB LEDs are, how they work, and how to use them with Raspberry Pi. If you are familiar with LEDs in general, then you know they are electronic components capable of generating light. LEDs come in different colors, and they usually have two pins. You need to observe polarity when building an LED circuit and use a resistor to limit the current that flows through it. Very simple. What makes RGB LEDs different compared to regular LEDs is that they actually are three LEDs in one package, each capable of emitting a primary color of either red, green, or blue. RGB LEDs have typically 4 pins, where 3 of the pins give us control of their respective primary color, and 1 pin being common. Having separate control over each primary color allows us to drive a combination of colors theoretically across the entire color wheel all the way to white. In practice, due to their low cost, typical RGB LEDs are limited to maybe 10 to 20 colors that we can distinguish with our eyes, but this is more than sufficient for many interesting electronics projects. Before you start building your first RGB LED circuit, you need to determine the type of RGB LED you have. The common pin configuration can be either common anode or common cathode, which in itself does not limit what you can do with the LED, but it makes a difference how you connect it to power with a small difference in setup and code. If you have a multimeter, you can determine your RGB LED type very easily using the LED test function. Connect one probe to the longest pin of your RGB LED, which is the common one, and the other probe to any of the other pins. My LED lit up with the negative multimeter probe connected to the common pin, which makes this LED common cathode. While I'm at it, I might as well test the other colors to make sure they work and to determine which pin is which color. Pinout information will be needed when you will be building your circuit and writing code. Let's test my other RGB LED. This time the LED did not light up. If your LED does not light up, reverse your multimeter probes. Based on my test, this LED is common anode type, since I had to connect the positive multimeter probe to the common pin for the LED to light up. If you do not have a multimeter, don't worry. Simply assume your RGB LED to be common cathode, and later in this video, I will show you how to figure this out without a multimeter. In case you are worried, RGB LED connected with polarity reversed will not get damaged, and it will not damage your Raspberry Pi. Speaking of a circuit, here's mine, already built. Each of the color pins is connected through a resistor to an available GPIO port. Any resistor values between 220 ohms and 1 kilo ohm will work. This RGB LED is common cathode type, so the common pin is connected to ground, unlike the common anode type, which would be connected to the 3.3 volt rail. Let's write a simple testing program to make sure that the circuit is built correctly. I will be using plain terminal with Nano Editor, but you can use your usual choice. Always start with Python 3 interpreter line. GPIO 0 has a ready class, aptly named RGB LED. I am planning to light up the primary colors in sequence, so a sleep function is needed. Now I need to declare an object of RGB LED type in the program, which is initialized with GPIO pin numbers for red, green, and blue in order. For common cathode, this is all the information required, but for common anode, you need to add an extra parameter called active_high and change the default value from true to false. I will put the default value in for your reference. Let's light up each of the primary colors for 2 seconds each in sequence. Each RGB LED color is specified as a 3-value tuple in red, green, blue order. Each color value ranges between 0 and 1, with 0 being off, 1 fully on, and a fraction of value in between for partial saturation. With that in mind, a color of 100 represents pure red, 010 represents pure green, and 001 represents pure blue. Of course, you can set more than one color at the same time. For example, setting all three values to 1 makes the LED emit white color. Let's run this program and see what happens. Everything appears in order. Here's the point where incorrectly identified RGB LED type, common anode versus common cathode, will be apparent. If your LED does not light up, or the colors are weird, check your program first, and then have a careful look at your circuit. Fix all mistakes and try again. You may need to change the pin order in LED initialization line if your colors are appearing out of order. Let me change my circuit to a common anode LED. The one difference from the common cathode circuit is where common pin is connected. This time, the common pin will be connected to 3.3 volts. If I run the test program as is, this LED will light up mostly, but the colors will be completely wrong. To fix that, I need to adjust the program by changing active high parameter to false, thus designating the LED in code as common anode. A repeated test run will confirm that the setup is correct. The goal is for your LED to display all colors correctly in the right order using the testing program, regardless of the LED type, before you move on. Now you are ready to make more interesting projects. You can start by trying coding samples I prepared for you. You can download them from my GitHub account using the following command. It can be found in the video description, so you can copy and paste it into your terminal. This command will create a directory called RGB-primer containing a number of Python programs, including the testing program I just wrote. Let's have a look at the RGB wheel program now. This program defines 12 example colors across the color wheel, which should look fairly well with most RGB LEDs. You can see here how fractional values control each primary color saturation. For example, the color named lime is produced with 50% red intensity, 100% green intensity, and with blue turned off. This program will cycle through these colors similarly to my earlier testing program. Let's run it to see it in action. You can stop the program using Ctrl+C if you don't want to wait for it to finish. The RGB Pulse program works with the same 12 example colors, demonstrating how to gradually change between two random colors, creating the appearance of a mood light. The core functionality here is contained in a loop that uses GPIO 0 RGB LED Pulse method. Let's have a look how this program works. This program will run indefinitely, so use Ctrl+C to stop it. My final example is RGB Sandbox, which will let you control all colors using the keyboard. This program is quite involved, so I decided to split the code into two files not to overwhelm you. The basic program contained in RGB Sandbox file, which you are looking at, has familiar elements, necessary imports at the top, and a main function that handles the RGB LED functionality on the breadboard. The rest of the code is in rgb_primer.py file. You can see the import statement at the top here. This support file contains code that is beyond beginner skill, but feel free to have a look and learn from it. Let's run the RGB Sandbox program. The program interface is straightforward, with the three rectangles representing on screen what is happening on the breadboard. Control key mappings are listed below. For example, you can use up and down arrows to adjust a specific primary color one click at a time. You can speed up the changes by holding the Shift key, or toggle a primary color using page up and down. Left and right arrows allow you to cycle through the primary colors, etc. I think this is fun, and I encourage you to give this example a try if you have the circuit. With this program, you can test the colors your LED is capable of producing. If you find a color that you like, this program will tell you what the respective RGB tuple values are, so you can replicate it in your own programs. That's it for this video. I hope you found it useful. Thanks for watching, and keep tinkering.